Many students mistakenly try to find a common denominator when multiplying fractions. That is not necessary. There is no need to find a common denominator between 4, 6, and 10 in the following multiplication of 3/4 times 5/6 times 7/10. All I need to do is multiply my numerators into my new numerator and divide that by the product of all the denominators. Again, no need to find a common denominator between 4, 6, and 10. Now, as the next step, many students will try to do their full calculation of multiplication, in this case, in the numerator, and then do the same in the denominator, and then do a long division process. I recommend on an exam, without any calculator, try and simplify the expression first. For example, I know 6 is really 3 times 2, so I can cancel top to bottom the 3 with the factor of 3 and 6. That really essentially becomes 1 and 2. So 3/6 is 1/2. Likewise, I see 5 and 10 essentially also becomes 1 over 2. And this simplifies my whole calculation. It now becomes 1 times 7 divided by 4 times 2 times 2. And the result of which is 7/16. In division, know that dividing by a fraction is the same as multiplying by the reciprocal. So for example, 3/4 divided by 1/2 really becomes 3/4 times the reciprocal of 1/2, or 2, divided by 1. It's essentially 1 over the fraction that I'm dividing by. And now it becomes a problem of multiplication just like above. 3 times 2 in my numerator, 4 times 1 in my denominator. Again, no need for common denominators. That only applies to addition and subtraction of fractions. And I could cancel and simplify here, 2, 1, and my result is 3/2. Likewise, I could look at a particular fraction by itself, say 3/4, essentially as 3 over 1, the fraction, divided by 4 over 1, which would be the same as multiplying by its reciprocal, 1/4. That is the same thing at the end of the day. Familiarity with fractions is a very important skill set for an exam without a calculator. Specifically, knowing how to convert and evaluate fractions in terms of decimals and percent is going to be very helpful for you on the exam. Now, 1/2, 1/4, 1/5, 1/3. Students are generally familiar with those conversions, but others might not be as commonly used and therefore not as well known. For example, 1/6 is 0.166, infinitely repeating. I could even round that to 0.167 if I liked. And then if I needed to find something like 5/6, I could either multiply that value by 5 or note that it's 1 minus 1/6. And that in turn is 1 minus, I'll use my rounded estimate, to become 0.833. And in fact, that's actually an infinite decimal as well. 1/7 is 0.1428, etc. Not a repeating decimal, but infinite. Again, I like to round that to 0.143 for quick calculation purposes. And then if I'm confronted with 3/7, I can simply multiply that value by 3. 3 times 14 is 42. 3 times the 3 becomes 0.429. And I can quickly use that for comparison purposes to other fractions or in some calculation on the exam. 1/9 is a nifty rule that everyone should know. Anything divided by 9, that is, any digit, is going to be that digit infinitely repeating. So, for example, if I had 5/9, that will just in turn be 0.55555 continually repeating. 7/9, 0.777 continually repeating decimal. A digit divided by 11 is also an infinitely repeating decimal, but in this case of alternating digits, which we'll have to compute. The first digit will always be 1 less than the digit in the numerator. In this case, it's 1, so 1 minus 0 is 0 for my first digit. My second digit will be 10 minus that. 10 minus 1 in this case is 9. So this in turn will be 0.09090909, infinitely repeating. And I quickly then figure out, say, 3/11. It's going to be 3 minus 1, so 0.2. And the next digit will be 10 minus 3, or 7. So it's 0.27, infinitely repeating. Let's try one more. 9/11, for example. That will work out to 0.9 minus 1 is 8. 10 minus 9 is 1. And that will be just 0.818181, infinitely repeating. 1/30th, you may not be as familiar with. It's simply 0.033, infinitely repeating. And that can be helpful in case I'm confronted with, say, 1/15th as a fraction. I'm going to know that's essentially equivalent to 2/30ths, which will then be twice 0.033, or just 0.0666, infinitely repeating. So this way, by knowing some of my lesser-known fractions, the 1/6, 1/7, 1/9, 1/11, and even to the level of 1/15th, 1/30th, can come in very handy and allow you to move through your exam more reliably and more efficiently. Students should also be very comfortable with calculating fractional discounts or fractional changes for the exam. So for example, if I start with 1 of anything, and I discount it by 1/3, my resulting price, for example, might be 2/3 the original price. And I can extend that to another period where if I then have 1/2 off of that price, that would in turn be 1/2 of the remainder that I started with, which is 2/3. So 1/2 times 2/3 leaves me at the end of 2 periods, simplifying 1/3 of the original price. Likewise, the discounts could be fractional increases. So if I had a stock that increased by 1/2, its resulting value would be 3/2 the original. And then suppose the next year it again increased by 1/2, so I'd be a very happy investor at that point. That would again be 3/2, but it would be 3/2 times my starting amount of 3/2, so 3/2 times 3/2. And my final value of my stock compared to the original price at the beginning would be 3 times 3 in the numerator, 9, divided by 2 times 2 is 4, or 9/4, the original price. So let's look at this in a simple word problem. John drinks 1/4 of the milk day 1, and then 1/3 the remainder on day 2. What fraction of milk is left? In this case, we'll want to assess our first discount. If he begins with 1 whole milk, he'll drink 1/4, so he'll reduce that amount on a fractional basis by 1/4, leaving him 3/4 of the original amount at the end of day 1. But then we're told he drinks 1/3 of that remaining amount, so he drinks 1/3 of the 3/4. So essentially what he'll be left with is 1 minus 1/3 times the starting amount of 3/4, which effectively is 2/3 times 3/4. 3's will cancel. 2 and 4 will reduce to 1/2. Fractional amount of milk left over will be 1/2, the original amount. That was a problem.